we'll move to the last speaker, which is a kind of a special solution. So we're talking hydrogen now. To me, that might be more of a kind of energy storage than electricity production. But I think it's really a hot topic and it fits here as well. So welcome, Johan. The floor is yours.
Hi, thank you. Hi, I'm Johan Guo, project leader at H2 Energy. We are a technology-based startup company just founded 2 years ago. Our innovation is a 3D printed catalytic reactor, short for eReformer. With the process around eReformer, we are able to convert a range of readily available green raw materials into green hydrogen and green CO2. These green raw materials can be biogas like syngas, landfill gas, and methane, or it can be green ethanol or green methanol, etc. As we all know, the subject of today's event, fossil-free energy. So I'm going to talk about how we achieve that, or how we are going to achieve that. If we look at every power production plant in the world, you see it's either coal or natural gas or something similar. They have to be replaced by something else in the future to produce electricity. And now wind or solar is interesting, but the problem is that they are intermittent, they are weather dependent. Sometimes they are not available, obviously. So you need to balance them in terms of frequency. So you need something that you can rely upon. Therefore, we think on-time and on-demand conversion of hydrogen is the key to solve that problem. And why conversion, some may ask? Basically, it is one of the few ways to balance and to distribute enormous amount of power needed when we are turning from a carbon-based society to a non-carbon-based society. Then why hydrogen? Well, the background for that is the fact that we believe that we will see an enormous amount of local distribute production units like electricity being driven by hydrogen. But that requires, because hydrogen is a tricky field, it is difficult to handle logistically. And that is the reason why we think on-site conversion is the key to this market. And we are talking about enormous amount of energy that has to be produced when we're going into a decarbonized society. So above all, that is a business intelligence concept, and now we need technology to realize it. So a group of scientists in KTH Royal Institute of Sweden developed a electrically heated catalytic process that can be used to crack hydrogen-rich gases, such as syngas, landfill gas, methane, ammonia, ethanol, etc. And due to its powerful feature, we are able to apply it on almost everything that is related to biogas. Well, because of the time limit, I can only give you a few examples here. Like gasification or pyrolysis. Well, I'm sure some of you or most of you have already know what they are. These two chemical processes turning unwanted waste into energy, like corn husk, rice husk, sawdust, etc. And during that process, syngas is produced. So we can use that syngas and convert it into hydrogen in a more efficient way. Now that we are in Sweden, it must mean something from a commercial perspective, right? So we did a little bit of research. In Sweden, around 250 terawatt hour of available forest can be used for industrial purpose in 2040. Thus, there are many players in this field. And biogas, including landfill gas produced, is estimated to be 2.2 terawatt hour in Sweden in 2020, equal to around 58,400 tons methane. Furthermore, such amount of biogas can produce 79,200 tons hydrogen and 435,600 carbon dioxide as negative emission. Well, another simple example here is that there are around 500,000 landfills in Europe, and they are leaking methane every day. By the way, methane is a greenhouse gas. So this is what we would do, or at least what we will do with our partner or client. We collect that leaking methane and turn it into green hydrogen and green CO2. Well, green CO2, let's talk about green CO2. Why do I call it green CO2? We have to look at the source. It is important that the source is green. And an easy way to understand that is that the biomass gasification. You see the source is unwanted waste. So carbon dioxide is almost cost as much as hydrogen, and especially it will be, because now lots of companies are coming up projects all over the world for synthetic fuel. The green hydrogen, the green CO2 can be collected and be electrolyzed to CO, carbon monoxide, and combine that green hydrogen to produce synthetic fuel. Synthetic fuel is also a carbon dioxide neutral alternative to conventional energy. It can be used in vehicles, aircrafts, ships, and even heating systems. Now, Porsche has announced that they are building a 15 million liter plant in Chile. Neste has one in Finland already to do the synthetic fuel, synthetic gasoline, and or aviation fuel. They're building one in Singapore, if my memory serves. But the problem is that their ideas is to take CO2 out of air, but that is extremely expensive because CO2 is only 400 ppm in atmosphere. It requires enormous amount of electricity to do that. So where to go? This is our time plan. Now we are in a demonstration plant. If this demonstration plan works, I think that we have a fair chance. We will collect the data, and so that we can decide small scale then, and if the small scale goes well, we will do the full scale. And in the end of the 2023, everything will be set up. So to sum up, our ultimate goal is to utilize something harmful or at least neutral to our environment and convert it into something that is benefit to our society without threatening the climate. Now, thank you. If you have any question, I will be happy to answer.
Thank you very much, Johan. I have a question for myself for now. So what is the best customer for your solution? Who is like the ultimate customer?
Well, best customer would be those gasification plant or pyrolysis plant, because in their chemical process, there will be syngas produced. And also there's another important application I haven't mentioned about, that's the tar. Tar is a problem to those pipeline, because they will shorten the lifetime of the factory. So we will be able to solve the tar cracking, the tar problem.
Thank you very much. So let's see, do we have any other general questions? We have a couple of minutes left, so
I have a question.
Yes,
Okay.
Johan, can you use, we have a very high heat, 530 degrees Celsius of steam. Can you use that so we could have a partnership somehow? Because our partner Uniper, they produce hydrogen, they have big plans for hydrogen, and it cannot be regular nuclear power is water-cooled reactors are useless for hydrogen production, but metal-cooled reactor is quite good. So how do you see that?
Well, well, actually, the problem is not, well, theoretically, if I put it this way, our invention, our innovation has no limit, because it's not only like for hydrogen production. You see a lot of chemical process in its either catalyst or temperature or high temperature. And the way we do it is that traditionally, they use the combustion to reach that high temperature, and we skip the combustion. We use electricity, and the way we're doing it is that the material is 3D printed alloy, and then we coat it with some other material, which I cannot tell you. And then the most important thing is that we have to make sure the stability of the coating catalyst and then the homogeneous of the material. If everything is under control, then every chemical process is, I don't see that as a problem.
Yeah, of course, we produce electricity. That was the first target of the Sealy reactor. But then, as a by-effect, we have this heat, which high quality heat. So by all means, our plan is to do direct fracking of create hydrogen with direct fracking. So we have some plans for that. But I thought maybe we should maybe talk. We are
yes.
Yeah, and see what we do together.
Yes, I'll contact you later.
Yeah, exactly, because hydrogen is a big hype. SMR, which we do, is a big hype. So let's talk and see if we can combine.
Yeah.
That's really good. I like to hear this type of this is all building networks and connections. So that's great. I got a question for you, Johan. Will you store or transport the hydrogen in liquid form or as a highly pressurized gas?
Well, that's a good question, because for now we only focus on this e-reformer, and we intended to solve this question in another way. We have a we are thinking about another reactor, but as liquid, and then with that new invention, we can sort of usually people do the people transport hydrogen, either use high pressure to make it liquefy it, or under the ground using pipeline, but that is not cost effectively. So we are thinking about because I said that we can convert ammonia into hydrogen, and we can do the other way around. We can convert hydrogen into ammonia, and then because the transportation of ammonia is much cheaper, and then after that when the logistic problem is solved, when the ammonia is on site, we can use our equipment to convert the ammonia back to hydrogen. That's our vision. It's a concept, but we are trying it.
Thanks a lot, Johan.